Hello Cloud Pedagogians, thanks for joining me in the second session of AWS Developers course. If you have come across my AWS Fundamental course, then you might be knowing how we deployed our student directory application. There we have added every piece of AWS service in different labs. In this lab, we are going to deploy the whole application at one stretch with compute, network, storage and database services. I'm not going to cover the monitoring and optimization section. My goal is to make my application functionality to work. Along with the world, the internet too is changing. Developers modify programs to keep up with these changes and hence update them. Main reasons are like to include feature addition, bug fixes, fixing security loopholes, etc. But here I'm just relaunching student directory application with all AWS resources that we have covered in AWS Fundamental course. In our case, we are just changing a few properties to our application. The first one is my application is moved from Amazon Linux 2 AMI to Linux 2023 AMI. Next, run the application on port 80. If you remember, in the fundamental course, we ran the application on port 8081. So, if you are ready, while it, go ahead with our task. In task 1, create an IAM role. In task 2, we will create a key pair. In task 3, create a default VPC. In task 4, create security group. In task 5, create S3 bucket. In task 6, create DynamoDB table. In task 7, finally deploy our EC2 instance. So jump with task 1, create an IAM role. You can use IAM roles to delegate access to your AWS resources. With IAM roles, you can establish trust relationship between your trusting account and other AWS trusted accounts. In our case, we want EC2 application to communicate with the database and storage. So let's create an IAM role for our application. Sign into the AWS Management Console and open IAM console. In the navigation pane of the console, choose roles and then click on create role. Select entity type as AWS service. Ours is a web application, so I'm selecting EC2 under use case. Choose next. IAM includes a list of AWS managed and customer managed policies in your account. Select the policies to use the permissions policy. Select S3 full access and DynamoDB full access permissions to add them to the role. Click on Next. Enter a role name and then review the role and then choose Create Role. Good job! You have successfully finished the task 1 by creating an IAM role for your application. In task 2, we are going to create a key pair. When you create a key pair using Amazon EC2, the public key is stored in Amazon EC2 and then you store the private key. Amazon AWS uses key pair to encrypt and decrypt login information. So when you launch a new instance, you assign a key pair to it. Then when you log into it, you use the private key. So let's generate a key pair for our application so that we can have a secure SSH connection. Open the Amazon EC2 console page. In the navigation pane under Network and Security, choose Key Pairs and then click Create Key Pair. Enter a name for the key pair. Amazon EC2 associate the public key with the name that you specify as the key name. So click Create Key Pair. Congratulations, you have successfully created the key pair for your application. In task 3, we are going to create a VPC. When you start using Amazon VPC for your application, you should create a custom VPC. Since it's a bit of consuming process to add in this lab, I'm using the default VPC configuration. But you can create your own VPC as we have already discussed in the fundamental course lab. If not, please check the description below for the link. Let's construct a VPC for our student directory application. On the VPC dashboard, click on Create VPC. For resource to create, choose VPC and More. Enter a name for your VPC, and here you can see 4 subnets. In each region, there is one public and one private subnets or exists. So click Create VPC. Good job! You have successfully created a VPC for your student directory application. In the task 4, we are going to create security groups. Although you can use the default security group for your instances, you might want to create your own groups to reflect the different roles that instances play in your system. So let's create security group for our application. In the navigation pane, choose security groups. Click on Create Security Group. Enter a descriptive name and then description. For VPC, choose the VPC that's created in previous task, like Student App VPC here. And you can add security group rules now. Add HTTP, HTTPS and SSH rules and then click Save. Good job! You have successfully created security group rules for your application. In the task 5, we are going to create S3 bucket to store our application photos. S3 is an object storage built to retrieve any amount of data from anywhere. In our case, we need to create the S3 bucket that will be utilized by the application to store the student photos. So let's create it. Open the Amazon S3 console. In the left navigation pane, choose Buckets and then click Create Bucket. Enter a unique name for your bucket and then click Create Bucket. Good job! You have successfully created the bucket for your application as well. In the task 6, we are going to create a table to store our student data. Amazon DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. In this task, we are going to create a student table for the application to write and read from. It's only one table and it's essentially a lookup table for our students. So let's create the table in DynamoDB. Open the DynamoDB console. Choose Create Table. Fill the table details. I am entering a table name as Students and partition key as ID. After filling in the details, click on Create. At this point, your table is ready for the application to add the data. Good job! You have successfully created the table for your application. In the task 7, we are going to deploy the EC2 instance. In this task, we are going to launch our student directory application using EC2 instance. So, open the EC2 console page, click on Launch Instance. Enter a name for the instance. In the application OS images, select Amazon Linux in AMI. Select Amazon Linux 2023. Let the instance type to be t2.micro itself. In the key pair section, select the key pair that's created in task 2. In the network section, click on Edit. Select the VPC that we have created in task 3 and make sure to change the subnet from private to public because our EC2 instance is a web page that it should be exposed to the internet. In the security group section, choose Select Existing Security Group. Make sure to enable the Auto Assign Public ID. In the drop-down, select the security group that was created in task 4. Scroll down and expand the Advanced section details. In the IAM role, select the role that's created in task 1. Finally, paste the user script in User Data section and then click on Launch Instance. The instance should now show up under Instances. Wait for the instance state to change to running and the status check to change to 2x2 checks passed. Note that often the status checks update and the UI doesn't. Feel free to refresh the page after a few minutes to minimizing waiting. Choose the checkbox to select the instance. Under the Details tab, copy the public IPv4 address. Paste it into a new browser tab or window. Now you should be able to see a student directory application homepage. Now let's see the functionality of the application. Click on Add button. We'll try to add a student with a picture. Enter the details. Browse the picture and then click on Save. I can see the status is saved. Let's verify that in the S3 bucket and DynamoDB table. As you can see here, S3 bucket holding a picture inside of the folder. Let's check in the DynamoDB table. Click on Explore Table Items. Here you can see a record that was entered from the front end. Next thing is we'll try to edit the same details from the front end. Click on Edit button and change the data here and click Save. And come back to the database and check the details are updated or not. See, as we can see here, the details are updated in the table as well. Finally, delete the student here and cross-verify the same in the bucket and table. I don't see a record in the table, but when I go to the S3 bucket, I can see the photos are still exist. Because SDA application is designed to delete the data from the table but not from the S3 bucket. So you still see the photos in the bucket, but these aren't connected to the application of EC2. Make sure you manually delete the photos if you don't want. Congratulations, you have successfully deployed student directory application in one stretch with compute, network, storage and database services in AWS. Final call, please don't forget to delete the resources that you have created in this lab to avoid the future charges from AWS. And this is the end of the lab to finish. I'm sure we'll see each other again in the next topic. Until then, take care.